Hey y'all, in this video let's talk about dependency injection in .NET but also in general. So if you're writing .NET server-side applications, you might be familiar with this principle, with how it works, so you can skip the first part. But if you are feeling like you are missing some sort of piece while we are using such a pattern, you probably want to stick around for the intro as well. So to talk about dependency injection, we have to understand where it's coming from. So dependency injection is a pattern that emerges from the dependency inversion principle. And this states that we are trying to avoid coupling in our code between low-level and high-level modules. So to even clarify that, we have to say what a dependency actually is. And it's a relationship between one object and another object. And we want to avoid that because that means that they are coupled. And such a coupling between modules that might be unrelated or are on a different level of abstraction may pollute our code. So as you can see, we have our module with dependencies, and it depends on some lower level implementation. And how we achieve the uncoupling of those modules? Well, we introduce an abstraction layer. So a perfect example of an abstraction layer is an interface that provides us with a clear list of the functionality that the higher level module can use, but it does not specify any implementation details. So it is up to the dependency that is implementing the interface to fulfill that data, fulfill that functionality, and higher level module does not have to worry about any of that. So now that we know the motive behind the dependency inversion principle, we have to think about how we can fulfill that in our code. So since we cannot simply create a interface type at the runtime in the higher level dependency, we have to think about what we can do to fulfill those dependencies without the higher level module knowing about them. And that's where dependency injection containers comes in. Such a container gets provided with a list of implementations as well as interfaces that those implementations fulfill and some implementation details for them as well. So the lifecycle of them or the scope of them, and they are getting fed into the dependency injection container, which is created at build time. And then at a runtime, whenever a module requires some dependency, it just asks the container, and the container, based on the rules that it was provided at the build time, knows exactly what to provide. But since retrieving dependencies is similar in a lot of cases, we developed some sort of conventions that help us just reduce the code necessary to retrieve dependencies. So for example, we have constructor injection that just knows that if a service that was previously registered with the dependency injection container, when it's provided as an argument to the constructor, it just knows that it should just instantiate the type that it knows about instead of failing because such a constructor wasn't filled in properly. There are also some other types like property injection, which just does the same but for properties. Method injection that does the same as constructor argument but for the method. So for example, if you have a service that requires a different type of dependency based on some argument in the method, that would be it. And an ambient as well, which we won't talk about in the scope of this video because it's more advanced and I just wanted to bring you some basics, but I just wanted you to be aware of that as well. So now that we know about dependency injection containers and what role do they fill in our application, we have to know that whenever we are registering a dependency in a container, we have to provide it with some extra details. And the most important one is the lifecycle of the dependency, because how it is created is a very important information to the container. So we have basically in .NET, in the basic dependency injection container, 3 types of life cycles. There are more, and if you are going with some more advanced containers, there are a lot of life cycles which we won't cover in the scope of this video, but for the most of the cases, those 3 are what you should know about. So transient just means that a new instance will be created each time a dependency is requested. Scope means that a service will be reused for a single request and never ever again. So whenever you have a web request, if a service is required for 3 or 4 or any amount of different services, it will reuse the same one for the same request. And there's also a singleton, which just means that the instance will live throughout the lifetime of an application until it is closed. So before jumping into code, we will be covering only the .NET built-in container. I just wanted you to know what are the differences and what are the use cases for the built-in .NET container that you are probably using. It is very simple, so it does not provide a lot of use cases. It provides only the constructor injection, and also it allows only for those 3 life cycles that were mentioned before. It does not allow for auto registering, decorators, injectors, some other different life cycles, property injection, and any other type of injection. Why is that? Well, they wanted to keep it simple, and the truth is that those use cases are probably the 99% that you may need in your day-to-day use cases that you are using in your application. Whenever you want to use something more advanced, you have the option, and some dependency injection containers are even built on top of the .NET one. So they give you the benefit of all your code working as it was previously working with those add-ons that allow you to register your dependencies in even more crazy ways. There are also some other older types of dependency injection containers that are not compatible, like Autofact. They were built before the .NET container was introduced, so before the .NET Core. So let's go into our code sample of our bookstore application. So dependency injection just allows us to inject some sort of services into our handler, and as you can see, I have an interface. We don't have to know how that interface is implemented in that delete handler. We just want to know that we want to have the functionality of the current user service. As you can see, we can also inject the class directly. If we know that we won't substitute for the dependency that we are trying to instantiate, it may be wise to inject the implementation as well. Those use cases are rare, but also creating interface just for the sake of creating it may be polluting your code. So you just have to know that there is an option of injecting the service directly, and it is not as big of an anti-pattern as you may think. Let's now navigate into how those dependencies are actually defined. So in our program CS or in our startup CS, we have the service collection exposed to us, and we have some methods that we can use on it to register our dependencies. There are 3 methods, each for the lifecycle that we have. So we have add transient, we have add scoped, and add singleton. And all of those provide the functionality that is pretty simple. If we use one type here, we will register our class as the class, and we won't be able to inject the interface. So in order to do that, we have to provide also the interface implementation, as I did here. And now we can inject our class as the interface. There are also non-typed versions, so if you don't have the type information, you can also use the method that provides you to just pass on the type parameter if you want to resolve something at runtime. Apart from those methods that are allowing you to add the services, there are also the add hosted service and add HTTP client, which are just more narrowed down functionality that is provided for some certain use cases. But I wanted you to know how that dependency injection actually works under the hood. So if you are writing some sort of console application where you don't have the ability of having the service collection being provided to you when you are creating the web builder, you can also just create your service collection yourself. So you can use the new service collection, and as you can see, the service collection is just simply a list that you may add some transients to, like the current user service, for example, and then you just build it and you get a service provider out of it. Oh. And that provider just has some methods to get the service that you may need. The get service just retrieves the service that you have implemented or not. So if you are sure that it should be registered, you may also use the get required service. So then I can just get my current user service, and it is my injected service. So under the hood, the dependency injection container just finds all of the constructors that it has. It checks if any of those arguments that are provided are not and are registered in it, so in the service collection that the web builder has, and then it just substitutes that interface or that class for the created by it via those lifecycle rules that you were specifying. Because even if you were trying to inject the application DB context directly here, it also has some dependencies. It also cannot be created without their own dependencies, so it helps you to cascadely resolve those as well. Because if you were trying to just create it directly in the constructor, you would have to know about all of the implementation details that its constructor has, and if anything changes, the fallback would be great and you would have to change a lot of code. So that's why the use case of injecting a class is also a valid one, and it is not polluting your code with some artificial interface that will never be used and is just not necessary. So I hope that was insightful into some really basic concepts of dependency injection in general, but also in .NET, that it is not some sort of magic. It's just a service collection under the hood that is doing all the work. It's just a glorified dictionary, a list, or whatever you want to look at it. And with that, I hope you guys enjoyed the video.